Okay, good. Okay, let's begin. Hello, everyone. Hello, welcome, welcome, welcome. Welcome to NUS Astro session this week. And my name is Wei Zhong. So I'll be giving the talk today. Uh, and the talk today is about treasures of the spring sky. Okay, so can everyone hear me clearly? Those at the back, if you can move forward, you can move forward a bit because got some very nice images to look at later. Anyway, okay, so treasures of the spring sky. So for those of you, right, who have a little bit of experience in astronomy, not too much, just a bit, you might be wondering what's so special about the spring sky, right? Because to be honest, the spring sky, on one hand, you lack the give me a moment. Is this can? Oops. Okay, yeah. So the spring sky, on one hand, all the dazzling constellations of winter like Orion, Canis Major, Gemini, and all those, they're all gone, right? I mean, so there's nothing too catchy. And on the other hand, the impressive Milky Way structures during the summer is not here yet. So spring is kind of stuck in an awkward place. Like you have a few bright stars, sure, but there's really not too much going on. Or is it? Because why would I spend an entire session talking about the sky if there's really nothing much going on? Well, there's one simple reason. My birthday is in spring. I'm a spring baby. Okay? This talk is all about my birthday. Okay, of course I'm kidding. I know people are gonna kill me if it really is like this. Okay, but okay, no. Okay. There's another very good reason, okay? But before I actually get into that, let's first clear up some ideas, some concepts, okay? When, where, what exactly is the spring sky? So the spring sky, for the most part, okay, there is no official definition, but the general consensus, the thing that most people probably agree on is the sky that you see around local midnight, around 12 a.m. to 1 p.m. 12 a.m. to 1 a.m. that kind of time, from the months of March to May. So around midnight of March, April, and May, around that, during local midnight, the sky that you see is roughly what we call the spring sky. Okay, there's no official definition, but I think this definition that I subscribe to should be quite recognizable to most amateur astronomers. All right, so the constellations that we generally will associate with this period of time, this patch of the sky, is what's shown here. Okay, kind of centered around Virgo and Leo that you see here. So the constellation that you see here, one of the biggest constellations, this is Virgo. Okay, Virgo is the second largest constellation in the entire sky by area. Okay, and then the largest is another one called Hydra, which is right here. Okay, the two largest ones are both here. Okay, anyway, so we have Virgo, and then some of its surrounding constellations. We have, for example, Bootes, Coma Berenices, Corvus Crater, Leo, Ursa Major, Centaurus, Crux. So these are just some of the constellations that we see. Not all, but this is the main area that we associate with the spring sky. Okay, and yeah, so if you look at this, there doesn't seem to be too much going on. I mean, yeah, you have a few bright stars like Arcturus and Spica, but that feels like about it, right? So what's so special? The simple reason is springtime is galaxies galore. Okay, springtime has more galaxies that are easily observable and that we can easily see in the night sky compared to other seasons. Okay, now for those of you who are familiar with, let's say, the cosmological principle, okay, you might be familiar with the idea that if we look far enough into the universe, technically every direction should look the same. Okay, but so why actually does the spring sky look a bit different? Well, true, in every direction in the night sky, there are galaxies to be observed. But the sky at and around Virgo, and the spring sky in general, is slightly more special because it has a higher concentration of galaxies that are closer to us. To understand why, okay, let us first try to understand our position in the universe. Okay, so you see here, this is the constellation of Virgo, and that's Bootes. So this is the region that we're going to be kind of focusing on today. So let's see why there are more galaxies in this region to be observed. Okay, so right now we're all on Earth, right? we can all agree that we are on Earth, right? Is anybody not think you are on Earth? All right, okay. Nobody on the moon, moon boys, whatever. Okay, good. So we're on Earth. We are somewhere around here, okay? And the Earth is part of the solar system. Fair enough, right? Can you catch on? Okay, we're part of the solar system. And the solar system is part of our galaxy called the Milky Way. Okay, so this picture, of course, is not the real picture of the Milky Way. This is the artist's impression of what the Milky Way might look like based on measurements and data that we have about the night sky, observations about the night sky. So this is an educated guess, and we are somewhere around here. Okay, so for those conspiracy theories out there, this is your CGI. This is 100% CGI, all CGI. Okay, but of course, it's based on educated guesses, based on the data that we have. Okay, so this is the Milky Way. Now that's not the end. The Milky Way is far from being the biggest thing. Okay, we in the Milky Way are actually part of a galaxy cluster. What is a galaxy cluster? Galaxy cluster, as the name suggests, is literally a cluster of galaxies. There's no other way to explain it. Okay, so it's a cluster of galaxies that is roughly bound together by gravity and perhaps interacting with each other within the same relatively small area in space, such that it forms a cluster. Well, as the name suggests, right? So the galaxy cluster we belong in is called the local group. And in the local group, there are three main galaxies. The biggest one is M31. Okay, that's the biggest galaxy that we can see in the night sky as well. The second biggest in the area is us. We're number 2. And then number 3, you have the Triangulum Galaxy, M33, the smaller one over there. So 3 main galaxies within our galaxy group. Not a really big one. There are a lot more galaxy groups with many more galaxies, but fair enough, this is home sweet home, okay? Yep. And then you have like a bunch of other little ones, you know, kids running around the playground. We're not going to talk about them today because they're too hard to see, but you know, little kids and minions, you know, if they come too close, we use our gravity and we gobble them up. So, yep. Now, this is our galaxy cluster. Nearby, there's another galaxy cluster called the Virgo cluster. Okay, so the Virgo cluster is about 50 plus million light years away, which sounds far away, but really not that much cosmically. Okay, now the Virgo cluster is one of the biggest galaxy clusters close to us. We'll see why in the next slide. But why do we call it the Virgo cluster? Simply said, if you're observing this cluster, you will realize that it lies in the constellation of Virgo when you're observing in the night sky. Okay, so if you remember the shape of Virgo, it's like a person lying down, right? So near the head, okay, is where you will find this cluster. Okay, so both us, the local group, and the Virgo cluster form the Virgo supercluster, a cluster of clusters. And there are a lot of clusters in this supercluster, right? So you can see from here, we are roughly there, local galactic group in red, roughly there, okay? And then you realize Virgo cluster is actually comes under this huge clump right over here, okay? Virgo cluster is, you can say, it's like the capital of our supercluster. It's the largest cluster in the area, okay? You remember the Virgo cluster alone holds about 3,000 to 6,000 galaxies, and that's a lot, okay? And it's really not that far away, about 50 million light years, which is relatively close. Okay, that's why, being the most densely populated by galaxies area in our local universe, the spring sky and therefore Virgo and its surrounding area, it has so much galaxies that can be easily observed. Okay, and also coincidentally, it's not just the Virgo supercluster. Okay, the next nearest supercluster near to us is called the Coma supercluster in the constellation of Coma Berenices, and so it happens it's just beside Virgo. So that's the reason why the spring sky has so many galaxies that are relatively close to us and easy to observe as compared to other seasons. All right, and with that, I hope that answers the question why there are more galaxies to be easily observed in the spring sky. So now we go into the ins and outs of the galaxy. This is the real deal, okay? And so just the point to note, okay, not all the galaxies that I'm talking about today are a part of the Virgo supercluster or the Virgo cluster, but they will all be observable in the spring sky. Okay? Yeah. So let's really begin. So the first object I want to cover is this thing called Macquarie's chain. This is pretty much a landmark, okay? One of the most well-known and well-photographed objects, well-observed objects in the spring sky, okay? So it's this galaxy chain called Macquarie's chain, And as you can see, why it's called Maclaurin's chain, why it's called a chain, is because it forms a very, very smooth and very, very elegant curve. Okay, you can feel the smoothness, a butter smooth curve. All right, and yeah, so in this chain, right, most of these galaxies are actually moving in the same direction with the same speed. They share a common velocity. Okay, because they are all part of the Virgo cluster. Okay, this you can see this as sort of the most prosperous part of the Virgo cluster. Okay, there are so many galaxies concentrated in this area. And the reason it's called Maclaurin's chain is because, well, the common motion was discovered by Benjamin Maclaurin in 1961 that you can see. And this area is filled with galaxies. I mean, in this picture, you probably can't tell so much. I mean, you have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. But let's see the next slide, and you'll realize that the true population of this area of the sky. Okay, this is the Maclaurin's chain. This is the same patch of sky that you're looking at. The first thing you might notice is, why are there so many black spots flying around? Okay, these black spots are actually there because astronomers use them to block out some of the foreground stars, to prevent them from being too overexposed and too bloated, to cover up some of the exposures in the back. Okay, so you can ignore them. The point is, all these faint fuzzies lying around. You can see in this picture, right? Every single faint fuzzy in this picture is a galaxy of its own. So you have like huge bunch here, you have another bunch here, and bunch here, and there, and all around, and a few huge galaxies. So that's why this area, I call it the sea of galaxies. If only the field of view was larger, going in every direction, there will be a lot more galaxies in this region as well. Okay, and so this is the Maclaurin's chain. This galaxy here is called M87, Messier 87. Remember it? We're going to be covering it later. Yeah. So before we actually get into that, let me turn your attention to one of these galaxies over here. Some of the most special looking galaxies. So this pair of galaxies here are called Maclaurin's eyes. Eyes because, well, the two of them. So according to astronomers, amateur astronomers, stargazers who look at them through telescope, there are two fuzzy dots, like two eyes. So they're called Maclaurin's eyes. So they are NGC 4435 and 4438. Okay, and they are a pair of interacting galaxies. That's why they look like they have such a strange shape, because of the gravitational interactions between them. We'll be covering interacting galaxies near to the end of this talk. Okay, so wait for that. And anyway, about the Maclaurin's chain just now, this is also one of the favorite targets for amateur astrophotographers and amateur stargazers to be able to look at, because it's so huge. It actually stretches across quite a distance in the sky. So many astronomers can actually be able to capture it with relatively small telescopes. As well as for the people who are visually observing through telescope, you can actually just hop from one galaxy to another and look at them all. Even though they look like nothing but faint fuzzies, but it can be quite interesting. But just to tempt down expectations, they cannot be seen from Singapore because of light pollution. But in darker sky like Malaysia or somewhere like this can be quite a spectacular target. And convenient because you have so many of them in the same area. Just scan and you have lots of targets to see. Okay, moving on. Let's go to another galaxy group here. This is called Leo's triplet. Leo's triplet because it's in Leo and there are three galaxies, so Leo triplet. Okay, it comprises of three main galaxies here. Okay, at the top there you have NGC 3628, then M66 and M65. So these two are spiral galaxies. That one's an H-on galaxy that we're observing. So the galaxy at the top is actually called Hamburger's galaxy. I think, can you see why? Hamburger's galaxy? I mean, fair enough, right? Like it does kind of look like a hamburger. So yeah. This galaxy cluster is also a very popular target because of the amount of space that these three galaxies span, and you can capture three in one, so very convenient as well. There are a lot of smaller galaxies in between, but they are not easily observed, so generally we cannot capture them. All right, yep. So credits to my friend Horny for contributing this image to me, this presentation. I think it's a fantastic image with a lot of details. All right, moving on to some of the more interesting galaxies. We're going to be talking about spiral galaxies, but before we start, let's start with an example. This is called the Pinwheel Galaxy, Messier 101. Okay? Now, Messier 101 is one of the most classic spiral galaxies out there. It is very easily recognizable, and a lot of people know it. A lot of people have observed it before. And because of the shape, okay, it's almost like it's like a very, very nice spiral, as you can see here, that there's just classic of this type of galaxy called grand design spiral galaxy, where you have a very clear defined arms. Okay, so this is in the constellation of Ursa Major, and it holds about a trillion stars, which is a lot. Okay, our Milky Way holds about 200 to 400 billion stars, so this is about 2.5 to 5 times the size of us. Okay, yeah, and I personally have observed this galaxy before from Malaysia, not from Singapore. I can't be seen in Singapore. So what you will really see is a very faint fuzzy, but you can see its arms very clearly with your own eyes. So it's quite an amazing experience. All right, so spiral galaxies. What exactly are they? Spiral galaxies, as the name suggests, they are spirals, galaxies shaped like spirals. And you can see, very close enough, you can see all the spiral arms over here. So most of them have clearly defined spiral structures. Some of them not so much, but in general, they will be recognizable as spiral structures. So here we have 3 examples, and you can observe some common things about them. Right, spiral arms tend to be a bit more bluish tinted in color. Okay, these spiral arms here and out there, and also they have significant presence of red patches. Okay, and then meanwhile the core is actually yellowish tinted. Okay, so why is that? Well, simply because the arms form more young stars. They are active sites of star formation, and the cores accumulate old stars. Why is that so? Let's find out. So more about the spiral structure. Okay, so there's a common misconception from some amateur astronomers that these spiral arms are actually like fan blades. They turn around together. Okay, that's a misconception. They don't. The arms themselves don't turn. Instead, they're kind of like waves of gravitational interaction. Okay, so for those of you who take physics or engineering, or you have taken physics before in secondary school, you might be familiar with this idea called longitudinal wave. Okay, so a longitudinal wave is like a wave that propagates like this with phases of compression and what's called a rarefaction. Okay, so this is kind of how, not exactly the clearest simulation, but this is kind of how it's like. For a better simulation, it looks like this. So you can see the waves are actually, waves are kind of moving a bit, but most of the motion comes in stars and objects that are scattered around the disk of the galaxy, moving in and out of the spiral arms. Okay, so they move in, they become compressed, and they move out. So what happens in this case? Around the disk of the galaxy, usually we have lots of gas and dust scattered about, right? So as this disk spins, some of the gas and the dust will move into the compressed regions, which are the spiral arms. So within the spiral arms, what happens? Gravitational interaction causes these clouds of gas and dust to start compressing down. Okay, because they're nudged, because they're disturbed. So these clouds of gas starts moving down closer and closer. And what happens then? When these clouds are compressed, they become energized, they become more energetic, and they start to give off light. And because most of them are rich in hydrogen, they start to give off light in hydrogen wavelength, which is called H alpha. Okay, and that causes a lot of spiral arms to have those kind of red patches around them. Now, as these gas clouds, nebulae now we call them, compress even further, they collapse and they form new stars. Eventually, they'll compress until a point where they become so energetic they ignite nuclear fusion, and then a star is born. Okay, so new and young stars that are born in these spiral arms, they tend to be young and very energetic. So they give off light in the more energetic side of the electromagnetic spectrum, specifically blue light. And that's why the arms tend to have a bluish tint. Okay? Now, as we move on, these stars will age, and then they will mix round and round around the galaxy, and then they will age. And then they start forming, they start losing angular momentum and orbital energy, and then they start moving inwards towards the core. Okay? So the core is actually kind of like a graveyard accumulating older stars. And these older stars, right, usually they are slightly more reddish or yellowish in color because they have aged, so they give off less energetic light. And that results in the core of galaxies looking generally more yellowish. So that's the pattern that you will observe consistently across many spiral galaxies. Okay? Anybody has any questions on this? How this works? All good? All good. Okay, let's move on then. Okay, now we have this galaxy called the Southern Pinwheel, Messier 83. This is also a very well-light galaxy. This is towards the southern sky in the constellation of Hydra. And yeah, it's one of the most well-known and well-studied galaxies of the southern skies, mostly because it's fairly bright. Okay, it's fairly bright compared to many other galaxies, and it's quite big also. So it's a very popular target amongst astrophotographers. This image, for example, is sent to me by one of my best friends in he's one of the top astrophotographers in Singapore. It's called Remus. Okay, so you can see a lot of that delicate detail within this image itself. So like I said just now, you can observe the galaxy and you can see the patterns that I mentioned just now. The arms tend to be more bluish with a lot of reddish patches, and the core is more yellowish, so it's consistent. Okay, and yep. So this is one of the galaxies that you might want to know, because um, if ever you get to photograph a galaxy, I think this is one of the top choices to go. And because it's fairly huge, so you don't need a huge telescope to be able to catch it. And it looks pretty good. It's very cool, right? Yep. So this is another spiral galaxy, also a very popular one. It's called Messier 106. Um, so this galaxy is in the constellation of Canis Major, which is in the northern sky, near to Ursa Major. Okay, so it's a very popular target because of how it looks. It looks pretty damn cool, right? Doesn't it? I mean, you have a lot of extensive hydrogen emission clouds extending out the core and throughout the entire galaxy. As well, the spiral arms extend actually very far out, and they're very far-reaching. And yeah, so this galaxy, right? If you go and search up the Wikipedia entry for it, you'll realize the Wikipedia image looks even better. It's taken by Hubble, and it just looks so sci-fi. It looks fantastic, and therefore this is one of the favorite galaxies of a lot of people. Yep. So now we have a different kind of spiral galaxy. It's also a spiral galaxy. For the most part, it works the same way, but it has a bar. That's why it's called a barred spiral galaxy. So if you see these two galaxies here in the middle, near the core, right, you have two bar-like objects here and here. Okay, so these bar-like objects are actually natural formations. Likely, scientists believe that they form by resonance of stars that are falling towards the core. So they come under orbital resonance, and then they form this almost solid structure that turns as one in this bar in the middle. So it's called a barred spiral galaxy. Most galaxies are barred spiral. Most spiral galaxies are barred spirals, including ours. Okay, it's estimated maybe 2/3 of spiral galaxies are all barred spirals. Yep, and we are one of them. So we have a bar in the center of our galaxy too. If you remember the picture, the simulation that I showed you earlier. All right. So this is another picture of a galaxy sent to me by my friend Remus. Okay, a very nice galaxy. It's also a barred spiral galaxy. You can see the bar in the middle, and also bluish arms and a very yellowish core. All right, it's a fantastic looking galaxy. I mean, look at those arms, very sexy. But this is not the sexiest galaxy. Okay, the sexiest galaxy, you can go and search it up, is called this galaxy called NGC 1365. It's in the autumn sky, so I did not include it in here. But if you go and search it up, it's like, wow, sexiest arms in galaxies. Okay, yeah. Anyway, okay, NGC 1365. It's one of my favorites. All right. Anyway, an excellent image over here. You can see a lot of details through the disk. Yep. Okay, this is my personal favorite. Okay, my personal favorite. It's called the Sombrero Galaxy. Why sombrero? Sombrero is the Mexican hat, if you know what it is. You might see in the next picture why people call it the Sombrero Galaxy. Anyway, yeah. So this is my favorite galaxy because it is one of the brightest galaxies in Virgo, and it has a very distinctive, very striking dust lane and a very prominent halo around it. This is one of the only two galaxies that I've ever observed from Singapore before. It was a very difficult observation, and just to tempt your expectations, I do not expect it to see it from here in NUS. Okay, I observed it from a darker spot in Pasir Ris. Unfortunately, it's no longer dark, but you know. So, but anyway, the actual observation when you're under darker skies, right, it looks just like this. Okay, you can see a very round halo, spherical halo, as well as a very striking dust lane just cutting through it, a dark lane just cutting through it. So, it's amazing to observe. Okay, this galaxy right here. And yeah, so with this angle of tilt, it gives viewers a very strong sense of depth. Not very obvious here. You'll see why in the next picture. Anyway, this picture was taken by my friend Honey and Ethan. So another excellent image, very well processed, taken in just under 4 hours with a Newtonian telescope. So this is the close-up image. Okay, this picture was taken by Hubble. It is the highest resolution picture ever taken by Hubble. One of the highest resolution images ever taken by Hubble. So perhaps from this image, it gives you a clearer idea of why it's called Sombrero Galaxy. I mean, the flat sides with the, yeah, I mean, well, I guess I can agree why they call it Sombrero Galaxy. I mean, I don't totally agree, but I can see where they're coming from. In any case, it's not as ridiculous as people telling me Aries looks like a goat. Okay, Aries does not look like a goat. One more person tells me Aries looks like a goat, right? I'm gonna send that person to the hospital for to check the eye, the brain, and whatever. Okay, Aries does not look like a goat. But okay, back to this guy. So this guy, I hope you can see why I love it so much, because of the very strong sense of depth, the 3D feeling you get observing it from this angle. I mean, this is the only angle, right? So it kind of, to me, it looks more like a stadium, and then you have some kind of bright magical performance in the middle, just glowing, and then yeah, people around the stadium and all that. So yeah, so this is my personal favorite, right? And also this is one of the easier galaxies to observe. It is. So if in future, when let's say Astro Bash starts, or we can all go to a darker sky, I think this is a must see. Okay. Okay, another favorites, very popular. It's called the Black Eye Galaxy. Messier 64 in the constellation of Coma Berenices. Supposedly called Black Eye Galaxy because the way it looks like someone punched it in the eye in the middle, or something, you know. And then you got a black eye. So yeah. So the interesting thing about this galaxy is that it has a very dense disk of dust in the middle. Okay, so dense that it can block out most of the light coming out of it near there. And another interesting thing is that this inner disk of dust and this outer disk of stars, right? They're actually rotating in different directions. They're called counter-rotating, okay, which is very uncommon among galaxies, but this is how it is. Okay, the inner disk and the outer disk are actually rotating in different directions. So that results, right, in a lot of push and tug and push near the boundary of where the inner disk and the outer disk meet. And we'll see exactly what that amounts to in the next slide. So let's zoom in near the center. Okay, so it looks kind of magical, like some kind of black magic eye thingy, you know. I don't know how to describe, but this is quite a stunning picture, okay, taken by Hubble. So as I said just now, the inner disk and the outer disk are actually rotating in different directions, and that leads to a lot of star formation at the boundary. So you can see quite obvious here that the boundary here is populated with a very bright blue ring. So this is the site of very active star formation because of the counter rotation that I mentioned just now. Yeah. So again, another popular target by amateur astronomers. Okay, now we move on to the next kind of galaxy called elliptical galaxies. I'm sorry, there's a drastic change in the drama that's going on, because spiral galaxies look amazing, whereas elliptical galaxies, for the most part, not so much. Okay, but we still have to know about them because they are still a very common type of galaxies. Okay, for the most part, they are just white blobs with really nothing much going on. Okay, and they are called elliptical galaxies because they tend to be elliptical or spheroidal in shape. They mean slightly ovalish. Okay, and most of them have very little gas and dust, so they have very little star formation remaining. So in elliptical galaxies, it tends to be that most of the stars in here are older because there's very little gas and dust to start the formation of new stars, unless of course another galaxy crashes into it, but it's not that common, and that's why most of them are actually older, whole older stars, and the galaxies themselves are also older. So this is one galaxy that we must know called M87 that I mentioned just now. This is the biggest boy on the block. It is the biggest galaxy within our local universe, within the Virgo supercluster. Okay, it has several trillion stars. Okay, just recapping, the Milky Way has about 200 to 400 billion. This has several trillion, so it's maybe about at least 10 times the size of the Milky Way, which is huge. Okay, and it's also home to a supermassive black hole as well as an ejected jet stream, and visually it's close to Maclaurin's chain in Virgo. So for those of you who remember, back in April 2019, astronomers released the first ever picture of a black hole. Now that black hole belongs to this galaxy. Okay, it's right there in this spot over here. Okay, so that's the picture of the supermassive black hole. It is so big. Okay, how do I put it? It is so big that, okay, let me put it this way. The sun is 300,000 times the mass of the Earth. Okay, we think the Earth is a pretty big place, right? right? I mean, our world feels like a pretty big place. At least our egos are. Well, um, now the sun is 300,000 times that of the Earth, and the black hole at the center of our galaxy is 4 million times that of our sun. Okay, 4 million times that of our sun. Okay, and this guy here is 1,000 to 2,000 times the mass of the galaxy at the center of our Milky Way. So that's how massive this is. 3 to 6 billion solar masses. Okay, times the mass of our sun. So yeah, and from this black hole, it ejects this stream of energy over here. Why is there this stream of energy? We will cover later. Okay, so just remember, M87 has this very stunning streak. Okay, this galaxy itself is not very difficult to observe, but the jet stream is. The only reports I've read of this stream being observed was in Australia, where they had a 40-inch telescope under bottle one skies. Then someone managed to observe this with their own eyes. So yeah. Okay, next galaxy is called IC1101. It sounds like a module. It sounds like a level 1000 module, but it is not. It is a galaxy. It's the second largest galaxy ever observed, holding about 100 trillion stars. So this you think that M87 with like several trillion is big. Well, this guy has 100 trillion, so much larger than that. And it lies within the Virgo constellation, but it's not part of the Virgo supercluster. For the record, most galaxies in the Virgo supercluster are within 100 million light years of us. Most. Okay, some maybe a bit more than that, but generally within 100 million light years. This guy is a billion light years away. Okay, so it's very far away. And okay, so the interesting thing about this is a few weeks ago, 3 to 4 weeks ago, when I was just starting to do these slides, this was still the largest galaxy ever observed. Less than 2 weeks ago, astronomers made a new discovery that there's one that's even bigger than this. Okay, so it's called Alcyona, something like that. You can go and search it up. Okay, and it's known that the size is bigger than this through radio measurements. Now, the current hypothesis is that that galaxy is just slightly bigger in terms of size, but it may not have as many stars as this galaxy. So this guy might still hold the title of having the most stars. We don't know yet. We don't know. Let's check the news, okay? As new discoveries are being made. Yep. Anyway, the discovery was just made less than 2 weeks ago, so I'm too lazy to edit it in, but just for you to know, okay? All right. So yeah, here is IC1101, and the next kind of galaxies is somewhere in the middle of spirals and elliptical. So they have a disc shape. In general, they have a disc shape, but they don't have arms, and also you can see they have very little gas remaining. They have no clearly defined arms. They have very little gas remaining, but some of them do still have quite a bit of dust just hanging around the galaxy. So just like elliptical galaxies, they tend to consist of older stars. So star formation activity is also very low, and the galaxies themselves are also relatively old. Okay. Now, this galaxy right here, Centaurus A. For those of you in the group, you might see that yesterday's APOD was this picture as well. So this galaxy is currently under debate whether it is an elliptical galaxy or a lenticular galaxy. So I just can't decide yet with the data that we have. Okay, just like just now, Sombrero Galaxy is also actually still under debate whether it's spiral or lenticular. But okay, but in general, I think the consensus is leaning towards spiral for M104. But anyway, Centaurus Galaxy is a very bright galaxy located in the southern sky in Centaurus. So if I remember correctly, I think it's the 5th or 6th largest galaxy. I have also visually observed it from Malaysia before. It also looks like two lobes, and then with a dark lane striking through the middle. Also very interesting to see, right? So it's one of the brightest galaxies in the night sky and fairly easy to observe from darker sites. And unlike most other elliptical or lenticular galaxies, there is very active star formation ongoing. Why? Because we'll explain. Okay. Anyway, this picture was taken again by my friend Remus. Also a very amazing picture with a lot of details in the dust lanes over here. Okay, so this picture of the Centaurus A is taken in different wavelengths. It's taken in radio wave and X wave, different wavelengths of the electromagnetic spectrum. Just now that one was optical, okay? This one is different. Now, why do you see two streams that are beaming out from two sides of the galaxy? That's because Centaurus A itself has what's called an active galactic nucleus. What's an active galactic nucleus? So this is the same thing that you'll find in M87, which also explains why M87 has a long stream coming out of it that you saw just now. Okay, so what happens is that when matter, right, let's say gas or dust, starts to fall towards the black hole in the middle. So likewise, there is a supermassive black hole in the middle. All right. So when gas, dust, and matter in general start falling towards the supermassive black hole in the middle, they don't usually fall straight in. Okay, they enter an orbit around it. Okay, it's called an accretion disk. What happens to the accretion disk is the gravity of the supermassive black hole is so strong that it compresses the matter orbiting it very strongly, and also because of the amount of gravity there is, where the growth in the force of gravity as you approach the black hole grows exponentially as you approach it, right? So the inner layers of the accretion disk and the outer layers orbit at very different speeds. So what happens as they move and move and move and move around? There's a lot of friction that's being and therefore a lot of energy that's being generated. So there's so much energy from this compression and this repeated friction that a lot of matter in the accretion disk is therefore blasted out. Okay, it's blasted out in a very energetic manner, very energetic manner, and that's why you see these two streams here. So in this picture right here, right, what you see is the blue wavelength is actually X-ray emission, means that the matter being pushed out is so energetic that they emit in the X-rays, whereas the orange light is radio emissions. The rest of the white light is optical. Okay, so yeah, another defining feature of active galactic nuclei is that they tend to emit a lot in X-rays. Okay. Yep. Okay. So we talk about active galactic nuclei, right? Let's call them in short AGNs. Okay. Now the AGNs are very energetic themselves, and the most energetic of AGNs is known as quasars. Okay, the most absolutely energetic ones of them. So quasars are very bright, and they tend to be very far away, and they're not that common, right? So one of the closest ones to us, and also one of the first to be discovered, is this quasar called 3C273 in the constellation of Virgo. Again, it's not in the Virgo supercluster because it's so far away, 2.5 billion light years away. If you remember just now, IC1101 was like a billion light years away, and that's pretty far away. This is 2.5 billion, okay? And yeah, it is 4 trillion times as bright as our sun, okay? How bright is that? So let's say this guy here, we put this guy here in the middle of our galaxy, near the core of the Milky Way, it would appear as almost as bright as the moon. Just think about it, okay? The core of our Milky Way, which we can't even observe from Singapore, if it was replaced by this guy, it would appear almost as bright as the moon, and you can read under its light. So that's how amazingly bright it can get, okay? So that's a huge number, 4 trillion times as luminous as our sun. And it's also the furthest object that amateur astronomers can possibly observe, because it has a magnitude of negative 12 point something, which is, sorry, magnitude of 12 point something, apparent magnitude of 12 point something, which makes it fairly observable by stargazers under relatively dark skies with sufficiently large telescopes. I have a friend who claims to have observed it from Malaysia. I have not, but he claims to have, so well, I think it really is possible. So 2.5 billion light years, this is really the furthest you can observe. Most other galaxies are about 100 to 200 million light years away. And this jet, okay, it also has a very strong jet. This is the jet, this little wisp here. It looks very small and very wispy here, but this jet here is 200,000 light years across. The Milky Way is just like barely over half of this. Okay, so it's almost double the diameter of the Milky Way, and that's the entire length of the jet stream here. So that gives you an idea of how incredibly powerful this object is. All right, now moving on. Okay, we're going to be talking about interacting galaxies. So before we get into interacting galaxies, this is a very interesting part. You're going to love the pictures, okay? Before we actually get into it, let's start with an example. This is called the Whirlpool Galaxy. It's also a spiral galaxy, a grand design spiral galaxy. So this is a pair of galaxies that are on course for collision, about to collide in the constellation of Canis Major or Ursa Major, somewhere near the boundary. And it's the first, and this, right, this galaxy here, they call it M51A, this is M51B. M51A was one of the first ever spiral galaxies to have its spiral structure discovered. Okay, the thing is that this galaxy back then when it was discovered, the spiral structure of it was observed and discovered. Astronomers didn't know that it was a galaxy, so they call it a nebula. Okay, so that's why here's it, first spiral nebula discovered, even though now we know it's a galaxy. But back then, people thought it was a nebula. People thought it's all part of the Milky Way, all the galaxies are part of the Milky Way. But until new discoveries were made eventually. So, as you can see here, they are in the process of galactic collision, early stages. This one is approaching it, and they are going to merge together soon. Okay, and so concentrating on this, you can actually see M51 is really a embodiment of the classic features of spiral galaxies. As mentioned just now, you have very clear bluish tints in the spiral arms here, as well as a lot of red patches and a yellowish core. So yeah, so this is also a very popular galaxy to observe. I have seen it from Malaysia before. It looked amazing. You can see the spiral arms. You can even see the bridge that connects the two galaxies together. So that was quite a fantastic experience. Unfortunately, you can't see here, so let's hope for borders to reopen, then we can go to darker skies to observe it. All right? Yep, so this is one of the most classic galaxies, spiral galaxies ever known. And now we want to go into another set of interacting galaxies. This pair is called the antenna galaxies, okay? The pair of colliding galaxies in Corvus, the constellation of Corvus, which is right beside Virgo as well. And what you see in this picture, right, is actually two galaxies that have just undergone collision. So there's very strong gravitational interaction going on within these galaxies, such that they become deformed in such a manner. And you can see from the structures around it, right? There's a lot of very bright red and very bright blue features all around the galaxy. What these mean is that there's a lot of interaction going on. There's a lot of compression, compressing all the gas and dust within these two galaxies, such that they collapse downwards and form very bright emission nebula, as well as intense star formation. So intense star formation, in this case, we call it starburst. All right, and yep. So this galaxy is subject to a lot of research in galactic collisions because, well, our Milky Way is about to collide with the Andromeda Galaxy 4.5 billion years time. So astronomers want to know what's going to happen to us. So we take samples from around the universe, and this is one of them that we look at. Now, you might be wondering, why is it called antenna galaxies? Where it looks like antenna? Well, this is why. Okay, this is the zoomed out version. The field of view that you saw just now is somewhere here. So here you can see two very long strings coming out. So these are what astronomers think looks like antenna. Okay, now why are there these two streams? These are called tidal tails. Okay, how does that form? So when two galaxies collide with each other, right, they don't really, smack into each other, because galaxies themselves are collections of stars, and those stars, right, are relatively small compared to the space in between them. Think about our sun, right? Our sun itself is not exactly a huge star, but our star to the next star, there's a lot of distance in between them. So that the same goes for most other galaxies. All right, and so when galaxies collide together, it tends to be that the stars within them the galaxies just pass through each other, and the stars within them just brush past each other. Okay, and then the galaxy, the gravitational interactions start to take hold, and then they start interacting, and they drag out this very long tail. So some of the stars get ejected out of the system, and some of them move closer together. Okay, we'll see a simulation in the next slide. So here are some more interacting galaxies, some more examples. Here you have NGC 5765, okay, in Virgo. So you can see some tidal tails over here as well, some dispersal, as well as, so this is a very classic one called mice galaxies. Supposedly it looks like two mice fighting each other, or running into each other, or long tails, and so it's called mice galaxies anyway. Okay, so yeah, and then so these two are probably in the early stages of collision. These two probably have already moved through each other once, and they are just starting to merge together. And this pair here, NGC 4567 and 4568 in Virgo, is probably also in the early stages of collision. This pair here, some of you might know it by its own name. It's called the Siamese twins, but this name has been dropped. So now we just call it by the NGC numbers. All right, so these are examples of galaxies that are colliding or about to collide. Now, so you might be wondering, why on earth are there tidal tails, right? So this simulation here shows you why. Okay, what you see here is the simulation when two galaxies crash together. Okay, two galaxies, they move together, and the gravitational fields interact, and this is what happens. So Okay, let's just take a moment to admire this animation. Okay, I somehow find these animations amazing, just mesmerizing, and they really give a good picture of what possibly could happen to galaxies by speeding everything up. Okay, so if you can see, a lot of these stars are ejected outwards, and a lot of gravitational fields are being caught on, and therefore they form streams of stars, and that's how these tidal tails actually form. Okay, if you're curious, you can go on YouTube and you search up Mars galaxies collision simulation, something like this. Okay, and you can actually find in one of the top results that a simulation of how the Mars galaxies look, what they look like today. Okay, they give you a thorough simulation, a sped up simulation of how these two galaxies interacted to form this tidal tails. All right. Yep. Okay, let's move on. So these are two more interacting galaxies. The one on the left, on your left, is very interesting, called the penguin and the egg, because it apparently looks like a penguin. I mean, like, yeah, I mean, it looks like a penguin. There's a penguin and the egg over here. In fact, it looks like what they call macaroni penguin or something like this, with whiskers near its head. So, yep. And then, yep. So what happens is that a galaxy is on course collision to this elliptical galaxy over here, and this elliptical galaxy is gravity is strong enough to start warping this galaxy over here. So it's warping it towards the elliptical galaxy. That's why it looks like this. Okay, so it should be in the early stages of collision. Yep, and you can see a lot of star formation already ongoing in the Penguin galaxy, and a lot of dust that's being warped. So this other galaxy here is called the Tadpole galaxy. It looks like a tadpole. Well, I don't think I need to explain this too much, right? So it has dragged out a very long tidal tail that can be seen, and the two galaxies are probably already in late stages of merging. So they should be collapsing down into one single galaxy soon. Right, and yep, this is an amazing picture by Hubble Space Telescope. You can see a lot of galaxies in the background as well. In fact, this one I think has a bit of tidal tail. I'm not sure why. Yep. Okay, moving on. So coming to an end soon. Okay, observing and photographing galaxies. Now, galaxies themselves are huge. They have trillions of stars, hundreds of billions or even trillions of stars, many of them. But the thing is, because they are all so far away, that they become incredibly difficult to observe. I mean, like, let's say nebulae. Okay, most nebulae are within our own galaxy. They are maybe tens or hundreds of light years out. Galaxies, the nearest galaxy to us, the Andromeda galaxy, is 2.5 million light years away. And that's still the closest one to us, okay? Most of them can be tens of millions of light years. Most of what you see in this presentation are tens of millions of light years away. And so it's very difficult to see them because they are so far away, which makes them very small and relatively dim. From somewhere like Singapore with our light pollution level, observing galaxies is incredibly difficult. If you can find a dark spot where, you know, there's not much direct and ambient light pollution, you probably could be able to observe like just a few of them, maybe like Andromeda galaxy, pretty much the only one that can possibly be observed easily. Not even easily, it's quite difficult to observe it in any case, okay? But so they mostly appear very small because they are also so far away, which means that you need relatively large telescopes with longer focal length to be able to see them, to be able to resolve them. So yeah, so it makes it challenging, but at the same time, it's highly rewarding to be able to see galaxies under darker skies. Because like I said, sometimes when you see the structures of galaxies, like the arms, the core, as well as the details within the galaxies, I think it's an amazing experience. Okay, and yep. So throughout this presentation, you can probably already tell that I love galaxies. I'm a huge enthusiast of observing galaxies. And why is that? There are two main reasons. The first reason is very simple. They look cool, right? They look super duper cool. They look very impressive. I hope you have been able to see some of the most classic examples in the presentation just now. So yes, reason number one, they look cool. Now reason number two, to explain that, let me first show you this picture over here. Okay, this picture is called Hubble Deep View. It's taken by the Hubble Space Telescope in 1997. So astronomers pointed the telescope at a very small patch of the sky, and then they started imaging there for 10 days continuously. So how small a patch of the sky? Well, just imagine you have a $1 coin, a Singapore $1 coin. I put it at the bus stop outside, and then I observe it from here. That kind of smallness, small spot, a small tiny patch in the sky, and then they started observing it. Okay, and this is what came out of it. In a relatively desolate part of the sky, particularly in Ursa Major, this this picture of galaxy just came out, and all of them are incredibly far away, hundreds of millions, not billions or tens of billions of light years out. All right, and yep. So in this picture lies why I think there's a true charm of galaxies. So if you can see in here, right, other than 1, 2, 3, about 4 of them, 3 or 4 of them, 3 or 4 stars, every single speck is a galaxy. To us, human beings, the biggest structures that we can observe as points of light are galaxies. Okay, I mean, we talk about galaxy structure, galaxy clusters, superclusters, or even you have clusters of clusters of clusters. You can go on to huge structures. Okay, but the fact is that the biggest single object that we can observe as human beings when we observe the night sky is our galaxies. Okay, and each of these galaxies hold hundreds of billions of stars. Some trillions, some tens of trillions, or hundreds of trillions. We don't know. Okay, so there are so many stars out there, and there are so many of them. There are hundreds of billions of galaxies, each holding hundreds of billions of trillions of stars, and there are hundreds of billions of them all across the night sky, across the entire universe. I know there's a lot of aliens, but that's the scale of it. It's difficult for us to comprehend. But the fact is that galaxies themselves provide an avenue for us to help us understand how truly big the universe is. I mean, the number of stars, the distance from us to them, as well as the number of them just in the night sky, I think it really embodies the endless possibilities that this universe carries. I like to think of it this way. Today, I might maybe if I'm in the dark sky and I'm just scanning through the sky, scanning through the Virgo cluster with my telescope, or maybe I am just looking at pictures of galaxies. I like to think of it this way. In the galaxy that I'm looking at, is there life? Is there someone in there? You know, we don't know. Okay, we might never know. But just imagine that somewhere out there in one of these galaxies, someone is also looking at their night sky and thinking, is there some life out there? Is there someone out there? And one of the galaxies they're looking at might just be the Milky Way. It might be us. So I don't know. I don't know how that makes you feel, but it kind of embodies why I love observing galaxies, because it carries a lot of rich possibilities that the universe carries. And I think that's amazing. It's kind of embodies the real spirit of astronomy and helps us to understand how huge the universe is and how tiny we are. So, yep. And now we're coming to an end. Acknowledgements. Special thanks to my friends Remus for the pictures of M83, NGC2903, and Centaurus A. Amazing pictures, as well as my friends Honey and Ethan for the pictures of Leo Triplet and M104. All other pictures are publicly available. You can find them on Wikipedia, Wikimedia Commons, or just Google them and you'll be able to see lots of pictures of them. Okay, so with that, we have come to the end. Thank you all very much. So please follow NUS Astronomical Society on our Instagram page. Please follow us on Instagram, else got a surprise coming in for you later. Also, follow us on our other social media channels. Follow me on my Instagram. And with that, does anybody have any questions about galaxies? Anything? Questions? No? Okay. Anyway, then that's it for now. Thank you all very much for your kind attention. You've been a great audience, and I hope through this presentation you learned to love galaxies as much as I have, and I hope you learn how to appreciate them better. All right, and okay, so nothing from anyone. Okay, then let's move on to the Kahoot quiz. Let's move on to the Kahoot quiz then. After each question, you just talk for a while. Then after any question. Okay. This picture was taken on a mountain in Taiwan. So it was a bottle one sky up there, and it looked absolutely amazing. Okay, Julian's doing some other stuff, so Yeah, okay, yeah, you can see the animation here. You can see a lot of meteors striking by. So this is a time lapse of about 2 hours. It was very cold up there. It was like 3 to 4 degrees, and yeah. Okay, let's move on to Kahoot. Everybody know how to use Kahoot? Anybody needs help on it? Okay. Okay, recording, okay? Yes, I'll QR. Is there a QR code to be shown? Yeah.你就输那个钉钉就好。Okay 吗 Okay, anybody still in the process of joining? Anyone? Or shall we begin? Okay. 5, 4, 3, 2, 1. Okay, let's start. 10 questions in total, so oops. So have fun. Which of the following is not a springtime constellation? Okay. So this kind of tests your general knowledge, okay? Not a springtime constellation, not a springtime constellation. Okay, yep, the answer is Orion. So this kind of tests you on your general knowledge, okay? Orion is a winter constellation. Okay, the rest are all springtime constellations that we covered just now. Okay? Alright, next question. Which of the galaxies generally consists of the oldest surviving stars? Correct, elliptical galaxies. So like we said just now, elliptical galaxies are usually running very low on gas and dust, so they have very little star formation going on. An exception might occur if another gas-rich galaxy crashes into it, but it doesn't happen all that often. So for the most part, they still consist of the oldest surviving stars. Okay, yep. Next question. True or false? Due to the immense sizes of galaxies, they tend to be very easy to observe even from Singapore. Yep, false. They are incredibly difficult to observe from Singapore, and because they are so far away, even though they are huge and massive. Okay, the next question. Which is my favorite galaxy? Testing if you were listening. Which is my favorite galaxy? Covert Galaxy, yay! Most of you are listening. Very good. Very good. Most of you are listening. Excellent. Okay, next question. Wow, whose name is blank? Which are following are defining features of the active galactic nuclei? There are two possible answers, just select one. Okay, relativistic jets and X-ray emissions. Spiral arms come in spiral galaxies. Okay, it is a feature of spiral galaxies, and spiral galaxies can have an active galactic nuclei, but not necessarily. So what really defines active galactic nuclei are the X-ray emissions and the jets that you saw just now. Okay, dazzling can occur anywhere. All right, next question. So spiral galaxy arms can be loosely understood as, a bit more time for this one because it's a longer text. Remember the animations that you saw just now? Okay, very good. Waves of gravitational interaction propagating around a galaxy. So they're like waves, like if you remember just now, longitudinal waves that move, that propagate within the galaxy as the stars move around. Okay? Yeah. So structures that orbit the core, like fan blades, this one we debunked it just now. They are not tentacles, they don't pull in other galaxies. It does not work this way. Okay? That's not how anything works. But you know, okay, formation from dispersal of stars from galactic collision. This one is referring to tidal tails, but that appears in colliding galaxies, interacting galaxies. Okay, so the answer is the blue one. Okay, move on. The black hole which humans took our first ever picture was from which galaxy? This one we mentioned just now also. The galaxy, the black hole is right there. Which galaxy does it belong to? Alright, M87, very good, okay? M64 is the Black Eye Galaxy. Okay, not this one. The Milky Way, we are trying to take a picture of our own supermassive black hole, but it's proving to be very difficult because there's a lot of dust in the way that's obscuring our view. Okay, moving on. When galaxies collide, which does not commonly happen? Not. Okay? Yep, very good. The stars themselves don't tend to collide. Okay, like I said just now, there's a vast distance between stars. So usually what happens, the galaxies just pass through each other. Okay, the stars just brush by and they don't really collide with each other. Okay, the rest do occur. Gas and dust are compressed, which is what you saw in the antenna galaxies. Long tidal tails does form, like you saw in Mice galaxy just now, as well as antenna galaxies. And stars are ejected, which is entirely possible from the gravitational interactions. Okay, next question. Okay, look at the picture, okay? This group of galaxies is known as, covered it right from the beginning. Alright, very good. Macarian chain, okay? We can't take a picture of our local group or Virgo supercluster because we're in it, and they're so big that we can't get out. So, yep. Leo's triplet is, well, triplet, so 3 galaxies. Alright, you all got it correct. Okay, the last question only has 1 correct answer. And I pray that you get it correct. Please get it correct. And be honest, okay? Okay, let's move on. Have you followed our Instagram page? Please get it correct. There's only 1 correct answer. If you have not, go and follow now. Who has not answered? Who has not answered? Who has not answered? This three. Who? Okay, very good. Most of you did. Those who didn't, go back and reflect. Okay, reflect on why it's so difficult to do a simple action. Just follow us on Instagram. Okay. Yeah. Okay. Go follow us on Instagram page. Okay. Not threatening. Not threatening. Okay. That's it. Nick Fan 99. Monka and we have a ghost as our champion today. Very good. All right, that's the end for our talk today. Thank you all very much. Yep. If anything, let me know. But otherwise, thank you all so much. And okay, let's move to the stargazing side. Hope the weather has improved from just now. All right. Thank you all very much.